Alright, so this is section 2.1, day 2. We're looking at graphs of functions and their derivatives. The biggest thing that you want to think about when you are graphing the derivative of a function is you kind of want to take a couple steps. Usually I first recommend to, let me choose a different color here. I'm going to say look at where the derivative, or what is considered our slope, equals 0. And then you're going to want to also, so actually let's do that first. So if we look at where our slope is 0, you can see it happens here at -3 if you draw on a horizontal tangent line. So I'm going to let f prime of x be represented by my blue color here. So I'm going to go ahead and say my slope is 0. My slope is 0, it looks like right about -1, so I'm going to also draw on that point. It looks like my slope is 0 about at 2, so I'm going to draw on that point also, and at 4 as well. The second step is go ahead and look at where the derivative, which is my slope, is positive versus negative. So you can see here for the before -3 my slope is negative, so I'm just going to put down that my slope is negative here. Okay, after -3 my slope becomes positive, and then my slope is negative again, still negative, and then after 4 it becomes positive again. When we do this, we're just sketching in the derivative, so then I'm going to say step 3 is go ahead and sketch f prime of x. It's not going to be exact, it's just going to be a rough estimate. So you can see before -3 my first derivative is negative, so my y values need to be negative. So I'm just going to say, okay, well I'm going to start down here. It doesn't have to be perfect, but my value should be negative because my first derivative, my slopes are negative. My slope then changes to being positive, so I'm going to go up to positive y values. And they're positive, but as we approach -1, they become kind of less positive. And then after -1, my slopes are negative, negative, negative. But I see I need to get back up to where my slope is 0 at 2, so I'm going to come back up here. However, after 2, my slope is still negative, and it's not until I get to 4 that my slope becomes positive again. Okay, so again, it's just a rough estimate, but follow these 3 steps. So figure out where the slope equals 0, look at where the derivative is positive versus negative, and then go ahead and sketch your first derivative graph. Okay, so let's look at another instance. The second one here. So again, first we're going to find where my slope is 0. So I'm going to plot those points, horizontal tangent lines. Okay, and then I'm going to put down my slope is positive, where it's negative, positive, and negative. Okay. Alright, so my slope starts out being positive, so it's going to have positive y values. It then changes to being negative until I reach 1. It's positive for a while, and then at 5 it changes to being negative. Okay, so there's my first derivative, and it's just an approximation. The only places that are exact in these graphs are at the zeros so far. Okay. Now when we get to this next problem, you're going to see that it's kind of interesting because we don't really have any horizontal tangent lines. I can't really draw one here at -1 or at 2. My function actually is not differentiable. I can't find the derivative. However, before that, I can find pretty much the exact derivative. It looks like my slope here is negative, and the slope is -1. After that, it looks like I go up 2 over 3, so slope is 2/3. And then the last one, it looks like my slope would go down 2 over 1, so slope is -2. Drawing it a bit more in my graph. Okay, so slope is -1 until we get up to 1. Don't actually know what the derivative is at -1, so I'm going to use an open circle. The slope is 2/3 from -1 to 1, but not -1 to 2. But again, I don't know what the slope is at 2, so I'm just going to leave an open circle. And then from 2 onwards, my slope is -2. Okay, all right. If you look on the back, it's a similar sort of problem, where you know you're going to have some open circles. The first section of our graph, it looks like the slope is -2/3, and then the slope is 1. The slope is, let's see, down, it looks like -3. The slope is here 1, and the slope is 0. Okay, so as I sketch my graph, I'm going to go ahead and draw these, and I'm going to probably add in a little bit more here. I'm going to maybe draw it in red this time so it's a little bit easier to see. All right, so negative 2/3. Okay, and then 1, negative 3, 1, and 0. Okay, all right. I'd probably pause the video at this point and try to do the matching on your own. Kind of think about what is the derivative going to look like. So for number 5, you can see that the graph is actually positive the entire time. So that means your first derivative is going to have positive y values the entire time. So like number 5 would go with letter B. Okay, so go ahead and pause it, try it on your own. All right, if you come back together, number 6, hopefully you got was letter C. You're going to see that your slope was negative and still negative, so C is negative the whole time, and then you have that vertical asymptote at about 3. Number 7 should go with A, and 8 should go with D. You do have another worksheet in class that we'll do together, and then you also have some textbook problems. If you have any questions, as always, let me know.